Alright, welcome to Chemistry Video 1.1. Here we're looking at chemistry matter, just some basic definitions. Define matter, chemistry, and substance. We're also going to be looking at comparing mass versus weight. And just some intro instructions to how to watch our flip videos. Make sure you put away all your distractions, turn off your phones or put them in a different room, iPod, etc. Try to watch this on the biggest screen you possibly can. Don't want anything else to bug you like Twitter or Facebook. Please pause and rewind frequently. If you need to go back and hear something again, rewind it. If you want to pause for a second to write some stuff down and then listen, go ahead and do that. But make sure you do those as you need to. And then in your notes, you should write some questions in the margins as you're going if you don't understand something. And there will be a chance at the end of the video to also ask if you have questions. Alright, so let's get started. So introduction to chemistry. Chemistry in the sciences is the study of matter and the changes it undergoes. Recall from physical science in years prior that matter is anything that takes up space and has mass. So that's what we're studying. That's what chemistry looks at. And it takes up space and has mass. And in chemistry, we oftentimes look at substances or chemicals. And a substance or a chemical is a specific piece of matter that has a definite or uniform composition. So for example, you can pour yourself a glass of water, and in that water is really not a pure substance. So if you have tap water in your glass of water, you have your H2O, the water that's in there, and oftentimes there's other minerals and things added to our water to make it safer for us to drink. If you get distilled water is where you get all those impurities out of there, and you do have pure H2O. So a substance is something that is basically pure. And we'll look at substances a little more closely later in this chapter. A couple substances I want to talk about are ozone. Ozone is a substance that protects us from harmful UV radiation from the sun. And ozone is O3, which is different from the oxygen that we breathe, which is O2. And oxygen by itself, as an atom, that's not a very common thing. Oxygen's mostly around as O2. But ozone is that substance that helps protect us from the sun's ultraviolet radiation. Ozone is formed through a natural process, which means we don't need any kind of human impact. It happens all on its own. The oxygen that we breathe, which is O2, is hit by sunlight and causes it to split apart into individual oxygen atoms, like this one right here. Well, not all of the oxygen splits apart, so I probably shouldn't have crossed all of these off. Not all of the oxygen splits apart, and O2 molecules can gain that extra O molecule there. And when they come together, O2 plus O, now it's 3 oxygens, now you make O3, which is ozone. And this is a model for how ozone is formed. Chlorofluorocarbons are kind of ozone's enemy. Chlorofluorocarbons, or CFCs, they're a man-made substance, so we have to make them. And these CFCs, they were used as a coolant in refrigerators, plastic foams, and propellants in spray cans a long time ago, and now they're banned. As CFCs concentration in the atmosphere increased over time, we noticed that a hole in the ozone started to form. And basically scientists saw the connection between those two things and realized CFCs were the cause of this hole in the ozone. So you can see here, at this point right here, the concentration stopped increasing because we decided that in 1990 that it's time for CFCs to be abolished because of their harm to the ozone. And as you can see, it's not dropping off very rapidly. In fact, it's kind of going down very slowly over time now. And it's going to take a while for these CFCs to go away, but eventually they will go away, and hopefully the hole in the ozone will repair itself. Take a quick little break here to look at mass versus weight. Mass is a measurement that reflects the amount of matter, while weight also reflects the amount of matter. The difference between the two is that mass is something that is independent of gravity, which means it doesn't depend on gravity, and weight does depend on gravity. So for example, if you weigh yourself in different locations, like if you're on Earth and you weigh 100 pounds, on the moon you would weigh less because the moon has less gravitational pull pulling you down towards it. Mass, on the other hand, is something that is independent of those two things. And the way that we actually mass things, and we don't do it anymore, we got a little more sophisticated balances nowadays, but back in the day, you used to put specific masses on this side, like maybe a 10-gram piece and a 15-gram piece. And over here you put your sample, and when they were completely balanced, that's when you knew you had the same amount of matter, 15 grams and 15 grams, on both sides. So masses are what scientists use because it's independent of weight. In chemistry, we talk about a different scale. So you might have heard of these two before, the macroscopic and the microscopic scale. The major difference there is macroscopic is things you can see with your own eyes, and the microscopic scale is things you need a microscope for. So now you're looking at a fly wing very close up. Here's an electron microscope looking even closer. You can see the hairs on the wing there. These are called the macro and microscopic scale. In chemistry, we like the sub-microscopic scale, or the atomic level. The atomic level is when we look at the atoms. We focus on even things that we can't see now. So on number 5 in your notes, the structure, composition, or behavior of matter can be explained at the sub-microscopic level, or also called the atomic level. All that we observe about matter depends on atoms and the changes they undergo. Hence, you're taking chemistry, studying atoms and the changes they undergo. Chemists, or chemistry, seeks to explain the submicroscopic events that lead to the macroscopic events that we can see. And one way that scientists will do this is by making models. And we already saw a model earlier. Here's what a model is, by the way. It's a visual, verbal, or mathematical representation of a submicroscopic event. So visual, kind of like this right here where I'm showing you what happens with pictures. Or we could have a verbal description, like a sentence written out, like a chemistry law or something like that. Or a mathematical representation, like a mathematical law, like PV equals PV. And we'll get into this in second semester. And I believe you touched on this in physical science as well. So let's go through our last model here. Here's a model of how the ozone now gets destroyed by those CFCs. So the sun also uses ultraviolet radiation to break up a CFC molecule, and it pops off one of the chlorine atoms like so. When it splits it, and that chlorine atom goes on, chlorine now comes together with O3, remember that's called ozone, and basically it steals an oxygen from ozone and turns it back into O2. And that's not a bad thing because we like to breathe that. But now that you don't have O3, O3's job was to block ultraviolet radiation to protect us. And what happens now is this ClO will find a single oxygen atom out there somewhere, combine with it, and make some more O2, kind of a good thing. However, when you destroy this, it can no longer protect us from the sun. And the question I ask you now is, why is this a bad thing? What's the real bad thing about this? And in class tomorrow, we will go over what that is. All right, good job.